Hey everyone, I've decided today to do some testing conversations. There's a lot of people failing the ring final test at the moment and the insulation resistance test, both in the write-ups, professional discussions, and the observations. And I feel it's just through a little bit of a lack of information, people not going into their guidance note threes and sort of really studying this. So I thought I'd just do a little video on it today to just sort of help you maybe um, try and crack this, like, because failing this all the time isn't great for you guys, right? So let's have a little flick forward to the testing at the ring final, and then I'm going to do a short series of testing, I think, because this is something that's real lack of knowledge here, right? So ring final test, and I'm just going to talk through it, guys, how to do it. So what we need to know really is like why we're doing the test, how we're doing the test, how to set the tester up correctly, and how to verify the results, right? So we're doing a ring final test to ensure that there is actually a ring there, right? And there's not a broken ring, there's not being split into two neutrals. So that's the whole point of this test. The test is broken down into three steps, right? As it's called in guidance note, three different steps. So step one, look, is your end to end. So that's when you test your line, your neutral, and your CPCs. Each end of the test. So you set your test at the continuity, and then you will test each end, right? So you're using your low resistance ohmmeter setting for this, the continuity setting, okay? Now step two, guys, is R1 plus Rn, right? This is where we will make a figure of eight between the incoming um, line and the outgoing neutral, and vice versa. So we're making a figure of eight, okay? And then we're going to test around the ring at each point. Now, I've had this where people have got the line and the neutral, and then they've tested the tester on the other line and neutral. That's not for a brand new ring final test, so that we're not going to do that. So what we're going to do is connect them together in the connector block. So the ring is now a figure of eight, and then you're going to test around the ring, okay? And you want that result really to be fundamentally the same, right? We're going to look at the results we're expecting in a minute, right? And then your third test or your third step is step three, which is R1 and R2. Okay. It is little R1 and little R2, as I spot the deliberate mistake there. The end result that we get would be the big R1, big R2. It's not massively a problem there, right? So we do exactly the same with the line and the CPC, make them into a figure of eight, test it around the ring, right? Now, guidance note three says that the result should slightly increase towards the center of the ring and then come back down. Don't know how you can find a middle of a ring, to be honest. I don't really know they define that. That's a ring there, my wedding ring, and I don't know where the center of that ring is, but there you go. That's a little debate for guidance note three to be had, but it'll go up slightly, but hardly noticeable. It'll fundamentally remain the same, right? So let's delve a bit deeper into the three steps and see what we're expecting. Okay, so end to end, if we're taking an example of a 2.5, 1.5 twin and CPC cable, which is generally what we're going to use in a ring, unless it's a commercial, then it'll all be the same. But um, we're expecting that the CPC to be 1.67 times higher on a twin and earth. It's a slightly smaller conductor, isn't it? So the calculation works out that we're looking for 1.67 times higher, right? You'll test the end-to-end step one, line to line, neutral to neutral, and CPC to CPC. Now we've got to get from those results here our expected results. And this is where everybody's falling down, right? So all you simply do, guys, is you take line to line, and this is for step two, right? So for line to line and neutral to neutral, in this example, we've got 0.10, okay? So 0.10 plus 0.10 equals 0.20. And then we just simply divide that by 4 to get 0.05. So when we've done the figure of 8 like that, and we test in round a ring, look, that is the result that we are expecting to get, right? Similarly, for step three, in this example, we said the CPC was 1.7, right? So the R2 CPC, right? So 1.10 plus 1.17 equals 0.27 in this example. Divide that by 4 and we get 0.07. So when we do the figure of 8 between the line and the CPC, the R1 and R2, right? And we test at every point, the result we're expecting is 0.07. Okay, so that is how to do that is how to do the ring final test. Okay. And that's it. I'm gonna break these down into short videos. I'm not gonna go into installation resistance. So that's it. There's 3 steps to the test. There's end to ends, R1 plus RN, R1 plus R2, and I've shown you the calculation of how to get your expected result. And don't forget to test at every point. If you've got a fused connection unit on there, you need to take it off and test that as well. Every single point of the ring needs to be tested. And the step 2 result is not really recorded anywhere. That could be recorded on the back of a test sheet, for example. But the highest result that you obtain from step 3 is the one that we will record as our R1 plus R2 for any given circuit. Okay, guys, I hope that's helped, and I hope that's really cleared up ring final testing, okay, and the calculations that we are going to need in order to pass your NVQ assessments and your AM2. Thank you very much indeed for your time.